All right, we're going to look at position vectors in this video. These are vectors that give the position of a point relative to a fixed origin. So suppose we're talking about the point P, which has coordinates -5, 12. And notice how that's where the vector is ending. The vector starts at the origin, which we call O, which of course is 0, 0. Well, there's a couple different ways we can write this. We say that vector OP, remember it starts at O, ends at P. This has components -5 for the x and then 12 for the y. Okay. We can also say that point P has position vector -5, 12. So sometimes we just refer to the actual point, which is P, and we say it has position vector -5, 12. So you can express it like we did up here, where it comes from point O and then goes to point P, but we could also just use the ending letter, which is P of course, and identify its vector. Alright, copy down this next example. We're given a couple points here, A and B, and the coordinates that go with those points, and we're looking to find vector AB. So geometrically, we've already done this. We know that if we were to graph it, so here is point A, 4, 2, and then point B would be a little bit inside that. Point B has coordinates 3, 7, and if we connect these with our vector from A to B, that's what it would look like. And of course, if we were to do this geometrically, we said to look at the x and the y component. If we look at the difference between the x values, you can see that is 1, and the difference between the y values would be 5. And so that means that our vector AB would be, well, we have to go to the left one, so that's -1 for the x component, and we have to go up 5, so that's +5 for the y component. Now, from here, suppose we're talking about 3D vectors. We're not going to be able to do this geometrically. We need another way. We need a formula. And so let's really take a look at what we're doing here to get these numbers. So how do we really get that -1? Well, notice how we did 3 minus 4. So we subtracted the x values. And to get that 5, what we did was we did the 7 minus the 2. Well, the 3 and the 7 came from B, and the 2 and the 4 came from A. So we really did B's numbers minus A's numbers. So let's generalize here a little bit. Let's call this point A, which is where the vector starts, the initial point. Okay, call it the initial point or the starting point. And let's refer to this point B as the terminal point. Okay, the ending point. So I have a little mini formula for you here. It's TP minus IP. This is not given to you, something you have to commit to memory, but it's the idea of the terminal point minus the initial point. So you're going to use that anytime you wish to find the vector between 2 points. Let's jot that down. Okay, there we go. So jot that down. We're going to use it anytime we wish to find the vector between 2 points. All right, like we see here, we have 2 points. All right, so now let's just tie this into the idea of a position vector. If we were to label this O at the origin, okay, keep in mind that if we're talking about the vector A, B, we're starting at A, we're ending at B. So think of A as like your starting city and B as your ending city. So another way to start at A and end at B would be to go through the origin. So you can travel down the vector from A to O and then from O to B. So we really have what we call vector addition here. So this vector AB is the same as, okay, so that journey would be the same as if you were to journey along the path from A to O and then from O to B. Yes, the other way would be much longer, but you would still end up at B. Well, this is the same as, remember, if we were to write this as a position vector that starts from O, this AO vector, if we were to flip it, recall how we said in a previous video that we could negate it. So AO is the same as the negation of OA, and we still have that plus OB. And what we're really looking at here, this negative OA, is really the negation of your initial point, because remember A was your initial point, plus this OB, well, that's really point B, that's your terminal point. So what you can kind of see here is that we flip these, TP minus IP. So this is the idea of just using vector addition to kind of confirm that we really have the ending point minus the starting point. By the way, I hope you enjoyed the background noise of my kids turning over the domino chips. That's what that was, in case you were wondering. Alright, so now we wish to find another vector, but this time our points are given to us as ordered triples. So we are in 3D. Keep in mind that when we have an ordered triple, it's just like an ordered pair, except now we have an x, a y, and a z. Alright, so if we're looking to find vector CD, we're going to use our formula of TP minus IP. So the terminal point minus the initial point means we're just going to do D's numbers minus C's numbers. So since this is a point, if we think about it as a position vector, what we can do is we can just take the point and rewrite it as a position vector. So there's D's numbers minus, and now we need C's numbers. So again, take that point C and write it as a position vector. Pretend it's coming from the origin O. Okay, so from there we can just subtract, and we have -3, 2, and 2. Okay, another quick one. Suppose this time, instead of being given the order pair or the order triple, now we're given two position vectors. Okay, so E has position vector 4, 1, and then we have 1 for F. We're looking to find FE, all right, that vector that starts at F and ends at E. So we're connecting the points F and E. So our formula says to do the terminal point minus the initial point. So just like before, we're going to start with E's numbers minus F's numbers, and we're going to do the simple math, and we're going to end up with 2, 4. And let's just take a look at this graphically just to further clarify. So if these are position vectors, and I just sketched where E is approximately as a point, so if the position vector is 4, 1, it really has coordinates 4, 1. And if F's position vector is 2, -3, it really has coordinates of 2, -3. So remember, if it's a position vector, it comes from the origin. So this E, having position vector 4, 1, is really this as a vector. And the F down here would look like that as a vector. Remember, if it's a position vector, it starts at the origin. So what we're really looking to do here is find vector FE, so that's the one connecting these 2 points. Okay, so if you were wondering how this ties into the idea of a position vector, all right, remember the position vector is just showing its location relative to the origin. Okay. All right, this example is a little bit more complicated because we're given a couple of vectors here, and notice that they are both in 3D. So if we look at these two vectors, notice they each share an H. The first one has a G in it, the second one has an I in it. We are looking to find vector GI. And again, because it's 3D, we can't really draw what's going on here. It's very difficult to visualize. If we were to kind of pretend what's happening here, just to kind of get a feel for it, pretend that is G and this is I in space. We know that we need to go from G to I. Well, we have this other point H somewhere out there that we're going to have to travel through. So we're going to have to go from G to H and then from H to I. So this vector GI is the same as traveling down the vector from G to H and then picking up from H and traveling to I. Either way, notice how we're getting to point I. Right? If you go from G to I directly, or you take the longer way, we are eventually getting to I. Okay, so we have a shortcut over here in GI, whereas this vector addition, think of it as the longer route. So we need that longer route to find the answer to the question here. Well, GH is 1, 2, 3. Plus, now wait a minute, notice how we have vector IH and we need vector HI. So we talked about how we need to negate the vector in order to flip-flop those letters. So we're really looking at 1, 2, 3 minus that 4, 5, 6. So our final answer here for our vector would be -3, -3, -3. Okay, so just going straight across and subtracting. So this would be our final answer for vector GI. Okay, last example here, we're given a couple ordered triples. So again, notice how it's not a vector. It's written as a point, as an ordered triple. So what we're looking to find here is the magnitude of vector AB. Now, we don't know what vector AB is yet, so we need to go ahead and find that. So this is where we said we're going to do the terminal point minus the initial point. And we're given those points, but we can think of it as a position vector where we just transform it from being a point to a vector. So I'm just going to flip these, I'm going to turn them and write it as a vector. So we do B's numbers first minus A's numbers second. So from there, we're going to write our vector for AB. So that would be -3, +3, and 1. So now what we need to do is we need to find the magnitude or the distance between these 2 points. Okay, so this is really the same as what we're trying to find up above because this is vector AB. And recall we said this is where we're going to use Pythagorean theorem. Just going to put all of those into our Pythagorean theorem. So that's 9 plus 9 plus 1. So that is going to be the square root of 19. Bye-bye.